Good morning, everyone. In previous classes, we have dealt with electrostatic and magnetostatic problem, which was related to the steady states, in which magnetic and electric property or the phenomena was independent to each other. Now, we will consider more general quantities depending upon the dynamic problem or depending upon the time, because time varying magnetic field produces time varying electric field and time varying electric field produces time varying magnetic field and vice versa. And these fields called electromagnetic fields rather than the only electric field or only magnetic fields. And the behavior of time dependent electromagnetic fields is described by the equation called Maxwell equation. And in 1962, Maxwell formulated the basic laws of electromagnetics in the form of four fundamental equations. And these equations was based on Gauss law of electrostatic, Gauss law of magnetostatic, Faraday law of electromagnetic induction, and last but not the least, the modified Ampere law. Now come to the point that why the study of electromagnetism is essential. Hence, we have discussed earlier that the Maxwell equation explain a diverse range of phenomena from why a compass needle points north to why car start when you turns the ignition key, and they are the basics for the functioning of such electromagnetic devices as electric motors, cyclotrons, TV transmitters and receivers, telephones, fax machines, radars, and microwave oven. Here, as we have just discussed that time varying electric field can produce time varying magnetic field, and time varying magnetic field produces time varying electric. These both fields are perpendicular to each other because, according to Maxwell, an oscillating moving charge continuously emits the wave, and this wave called electromagnetic wave. An accelerating charge leads to accelerating motions, due to which the magnetic phenomena is produced due to accelerating charge. Hence, the velocity of charges changes. Due to this, the magnetic field also changes with the time, which leads the time varying electric fields. And as shown in the figure, that uh, both electric field and magnetic fields are perpendicular to each other. And these both field, electric field and magnetic field, are also perpendicular to the third field, which is the direction propagation of wave. And the wave associated with the oscillations called the electromagnetic wave. Now we will consider some basic laws of Maxwell equations that, as we have discussed in the previous slide, that the Maxwell's shows the four basic equations: Gauss law of electrostatic, Gauss law of magnetostatic, Faraday law of electromagnetic inductions, and the Ampere law. Now we will consider that uh, what the Gauss law of electrostatic says. According to the Gauss law of electrostatic, uh, the electric flux can be described by Q upon epsilon naught, and by the Gauss law of magnetostatics, The total magnetic flux is G0, as we have read or studied it in the previous classes or in the 12th phase or intermediate classes. According to the Faraday law of electromagnetic induction, uh, there should be the electromotive force should be equal to the negative rate of change of magnetic flux. And last but not the least, the modified Ampere laws. According to a modified Ampere law, the electric current and changing electric flux produces the magnetic. And this is our aim to understand these equations. Okay, thank you. The rest of the part will be discussed to the next video. Thank you.